On my last video, I went through a design of a buck converter using LM3670, and the focus of the design was on the buck converter itself, but I used a USB-C connector to deliver the 5 volts that we needed. After uploading the video, I realized that there is a difference between the standards for USB 2.0 and USB-C. So what we need to do is add two 5.1K resistors to the CC line. So that's CC1 and CC2. So thank you for the comment that somebody left on my channel. Today I'm going to go through updating this PCB design to include those two resistors, as well as the calculations on the datasheet for this part. So let's get started. So when using a USB-C connector, the standard uses two lines on the connector to sense when the plug is plugged in, and also when the plugs are reversed as well. These resistor values determine the power draw that we can take from the upstream or the downstream, power source. Generally, we can put down a 5.1K resistor, and that would give us the maximum capability from the source. Obviously, what we would need to be careful with is that the source can provide the power we need. However, in this case, the regulator is only rated to 300 milliamps, so we should be okay. So let's start making the design changes. So first of all, I'm going to start by adding the two 5K resistors. So I've pressed the A button on my keyboard, which brings up the options to put down resistors or any of the components. So typing in R, we should get a resistive component there. And what I'm going to do is just put down two resistors of 5.1K. So copy this and connect them to the ground and the CC lines. Notice that on here it says VCon, however that is one of the CC lines. That's CC1 and CC2. And then I'm going to connect that to ground. After connecting these two resistors up, obviously we'll need to change the PCB design, and we'll need to run the component assignment tool to kind of find the footprints that we need for the two resistors. I'm going to try to use as small as possible, so I'll go for 0402 resistor sizes. So these are the two new components that we put down. And to change the footprints, basically we want to go down to resistor and SMD, so this part here. And I want to use 0402 in this case, but I'm going to use hand solder because when I build this board, I'll be able to solder the components a little bit easier. 0402 can be a bit fiddly, so if you're not that confident with your soldering, then I suggest going up to 0603 if you're going to be using this as a reference. So now that we've added the footprints for both of these, I can save that board and open the PCB design. So this was the PCB design that we did previously. What I'm going to do is introduce the two new components. But first I'm going to remove some of the tracks so that I don't mess up any of the existing things. So I'll move this out the way, and to bring in the new components from the schematic, we press this symbol here. So update PCB with changes made to schematic. So just press update, and that should bring us our two resistors. We got R1 and R2. You can see R1 is connected to the bottom side, so I'm going to try and place it somewhere there. And R2 is connected to this pin here, so I'm going to try and place that there. Another thing I'm going to do, so I think it's just for neatness rather than anything else, is go in here and label these two lines. So CC1, and then add a label here for CC2. Save that. and import the changes again to the PCB design. You can see that the labels have updated now. So just moving these out the way for now, bringing the USB connector back into its place. Ideally, we want some clearance from the edge of the board. So what I'm going to do is increase the size of the board a little bit here. I want to move that out. You can see that the y-axis is 76.25, so I'm going to move that to 75, which takes it up. Obviously, that's a little bit too big, but we can sort that out later. I'm going to move this down as well. So move this component next to this one here, and move this one out here. Make sure to get the silk screens properly aligned. Now we need to get this connection to this resistor here. Firstly, so if I get rid of all the ground connections first and the power connections and just focus on doing the CC connections first, I think I'm going to move this part, or all of this part, I'm just going to move things out the way for now, and then we can sort it out later. So I'm going to bring these back in. Around here. Might do that later. So just focusing on the CC connections, connect that up. And then bring these parts back in. Next thing we need to do is get the 5-volt and the ground lines connected up. I think it may be easier to run the lines through here. I'm gonna bring the ground plane back in. And the other planes that I also removed, I'm gonna put them back in here as well. So this was the SW node, the switch node, and then this was the 3v3 node. Put that over there, shrink it to size. And this node was for the 5-volt 5v5, so I'm going to put that down there. What I need to do is basically remove this section from the ground plane. I'll basically go in here add in an extra node pressing the insert button here, and then another one there, so I can do this, and then insert again. So I got another node here to control that fill zone. So you can see this is filled in here. However, you can see it's not making a connection to this point, and that's because of the clearance that you have on this. What you need to do is check with the PCB suppliers to make sure that you can meet clearance that you put down. So if you obviously go too small a clearance here, the PCB design house might not be able to make that for you, or they might charge you extra money to get the boards manufactured. You can see we've got those connections in now. And in the end, we haven't increased the board size too much. We have basically got the connections in place. So I think this one running through there is fine. I do need to connect this node back up to here. So what I'm going to do is this ground plane, I'm going to add a few more nodes in. So I'm going to add in a node here and basically bring that, a node there to bring that down to there. And all that will mean is that I can connect the second 5v5 line to this point here as well. So I want to bring this point down, and then add in a few nodes, pressing the insert key, pressing the insert key again. The software will maintain the clearance for you that you've put down on there. So you see on this fill zone, we had a clearance of 0.3. So that's obviously made that clearance for you. And it does have a priority list as well. So obviously it's not prioritizing for the 5-volt line in this case. I'm going to bring this down here just to tidy that up a little bit, and then add in a track. And make the thickness of that track 0.5. Should have selected multiple ones, so make that 0.5, save, and press the B button to update the fill zones. The last thing that we need to do now is basically make sure everything's connected. So you can see on here that this ground plane is not connected at the moment. So what we need to do is basically add a connection point or bring the fill zone down. So we can do that here. I'm going to add another. You can see those points are connected now. However, this point is not connected to this point here. So all of this ground plane is kind of not connected at the moment. So there's multiple ways of solving that. We can add wires to circumvent that, or we can change the tracks around. So the simplest way I think right now is to increase the surrounding edge. I want to bring this down a little bit to close the gaps. we've got this ground node connected up now, and what I'm going to do is basically we don't need the extra spaces we here, so we need to close up the board itself, and I'm going to move this up slightly just to I'm going to move out these headers to the edge of the board, and then close off the board itself. I think we can bring this down here, increase the size of this, bring this down there. I'm not particularly worried about the size of this board, but obviously you might be. Then you might want to consider going to a two-layer design, and then you can make some of the connections a little bit easier. So we can shrink the size of this board a little bit by bringing these in as well, as we don't need to have the extra spaces around here. Obviously, you might not be designing this board with the two headers that I've got it here. So obviously feel free to change it as you need. I'm just going to shrink this board down to the size that I need. And then increase the fill zone here. And decrease this fill zone. Typically, you should not get the fill zone going all the way to the edge of the board. However, in this case, it is. I'm not too sure why. But we can fix that as well. So I'm just going to bring these in a little bit. So you should have some clearance here. The PCB supplier won't be able to manufacture a board without cutting into the copper. So obviously you want to limit where the copper is going to. And just tidying up the connections. So now just to kind of evaluate this board a little bit, so we now have a nice thick copper pad or copper traces going from the 5 volt to the input of our regulator. We have a really nice thick plane on the 3v3 output, and we have a decent ground plane. I mean, I think it might be better in this case to go to a two-layer design and change the ground plane to make it on the other side. So I'm just considering doing that. Other than that, I think it's okay. The only bits I'm worried about is basically these short track connections here. But however, if you imagine the connector here, the shell will be connected to this side as well. So these tracks, and I don't think they're 100% necessary anyway. When you start including the connector into the thing as well. So finally, let's have a quick look at the 3D design of this. You can see I've not got this in line, so I'll fix that. I've got some overlapping silk screens as well, so I need to fix that. The connector looks okay. Don't have any other tracks on the bottom side. I think the next design I do, I'm thinking to do a boost converter. I'll make it double-sided, and I think that'll be the best way forward to make the designs a little bit simpler, and the cost of a double-sided board isn't that high anyway. So let's fix our silk screens. So I've got J3 here, which is a ground connection. I've got 3v3, which is J2. I'll just fix that. I'll move that up there, move that back there, and move the reference for L1. Okay, I think that looks okay. You see I've got R1 that's overlapping that C2. So it's a good thing if you can see all the reference labels on the same plane. Just makes it a little bit easier to read for the person building the board. So a quick review again on the 3D viewer. I think that might be a bit too close to the edge of the board. Might be okay, I'm not too sure. Doesn't matter. I'm going to leave that as it is. Got a weird track here. I'll go ahead and fix that. And I'll fix this as well. Another thing we've not done is updated the bill of materials. So I'm just going to go into the bill of materials and add in the new parts. So we've got line 6, R1, and R2, 5.11K. Find the closest value you can on the 96 series. I think it's 5.11. And I've not sourced the part, but you should be able to find these components very easily and fill in the requirements here. The last thing to do now is create the manufacturing files. I'll just move this out the way slightly. Change the grid size to 0.1. So I've got a finer control. There you go. So it's not overlapping any of the silk screens anymore. The last thing to do is run a DRC check. So we want to make sure we have not missed any connections or anything too crucial. We looked at the hole clearances on the last time. There's not much we can do about that. There are no other errors, so I think we're okay. So save that, and I will create the manufacturing file. So you press this button here, select the layers that you need to print. So in this case, obviously we don't have any layers on the back copper. I'm not going to print any of the back copper layers. And I will basically select a folder called Gerbers and click yes. So plot, so that's created all my files that I need, and then the drill files. That tells where to drill basically all of these bits here. And close that. So we are done with the new PCB design. I'll upload this to Google Drive and put a video in the link below or in the comment section or whatever. And then the last thing, I'll update the last video with these new files. Saying that, I just realized there's an extra track here, so let's do that again. So we're done with the design now. Obviously, I've not tested this, so use it at your own risk. I think it's more for learning rather than using this for something on a project that you're kind of depending on to do well. I would, if you're gonna use the files, test it first. Make sure you check my calculations and my assumptions that I've made as well.